Hello, welcome everyone to Learn Competitive Programming with CodeChef channel. Today, I'm Nishchay Manwani and I'm going to conduct the second lecture on problem solving for number theory. I conducted one lecture yesterday at 9 p.m. So you can check it out if you want to. But in this lecture, I'm going to be solving two problems, both surrounding around number theory. The first is sequence summation. uh, I'll be doing this in the first half, and in the second half, I'll be doing Aragorn's racing dilemma, right? Both of these questions you can find on CodeChef. The first problem code is Geek05, and the second problem code is Top2. So, an introduction about myself. I'm Nishchay Manwani. You guys might know me as Zeus Source on codeforces.com, where I am All India Rank 3 and International Grandmaster, or NM at codechef.com, 7-star, currently All India Rank 12. I also recently joined as an educator in Unacademy. Uh, Recently, Unacademy has started a program on competitive programming and have brought in many talented educators. So I wanted to brief you about the program on competitive programming that Unacademy has. So if you do join this program, what will you get? You will get live interactive classes with these educators where you will be asking doubts and I'll be solving them immediately, or I will be asking you questions, you can answer them. You will also get relevant problems at CodeChef. I myself pick the questions relevant to the topic and give you guys those questions so you can solve them. And I give many questions so you don't ever have uh, emptiness of like problems, a lack of problems, sorry. And there will always be doubt support. I will be solving your doubts offline or in the class as well. And there are many teaching assistants, you can also ask them anytime during class or outside of classes as well, right? So the educators, like all of the educators have really strong backgrounds in competitive programming. There are people who have gone to ICPC World Finals. There are people who have won IOI medals, and there are people who work in the dream companies like Google, LinkedIn, Facebook, etc. Right? Also, there are people who have nice ratings on CodeForces or CodeShift.com. There are people like Tanuj Khattar, who is a 2 times world finalist in 2017 and 2018. Himanshu Singh, Deepak Kaur, also world finalist. Arjun P, he's an IOI bronze medalist. Murugan S, a software engineer at Google, right? Then there is me and Pulkit, both have like nice ratings on CodeForces or CodeChef. So the educators are really nice. So you would be able to understand most of the things from them, or they would absolutely be amazing at solving doubts, because I know most of the things, whereas beginners, like get stuck at. The topic wise structure is going to be like, there are going to be some beginner topics as well. We're going to cover introduction to programming, Java, C++, Python. These are absolutely basics. Even if you don't know programming, you can go to these courses. But if you do know a little bit of programming and you want to get into the competitive programming part, then there is data structures, STLs, number theory. The number theory is the course which I'm taking currently, sorting and searching, recursion, DP, greedy, etc. Then there are advanced topics as well, which would be our specialty. There are segment trees, graphs. These are all kind of intermediate in competitive programming. There are also going to be more advanced topics than these, right? Then there are miscellaneous topics as well. ICPC regionals plus world finals problem solving. Himanshu Singh, who is a world finalist himself, is currently solving problems from previous world finals or previous regionals, right? So you can also get into that course. So these are all the courses that are up on Unacademy right now. And you can go and watch the previous lectures that I have taken on number theory as well, or in any of these courses, right? Or if you are completely new, you can go to watch standard template library in C++ and see those videos, and then get to the current class and ask the teacher the doubts in the current classes as well, right? So this is the forum where teaching assistants on Unacademy will solve your doubts. And this is the platform where I would be putting up the practice problems that you have to solve, right? The pricing plan, there are some currently special classes on Unacademy. So if you just want to see how Unacademy works and what kind of teaching methods educators are using, you can go and watch those. Those are completely free. I have a three special lectures on Sieve, right? Or you can just watch this YouTube lecture as well. It will be the similar in my live classes, right? If you do like these videos, then you can go to Unacademy. Currently, we have for the first month we are giving away 1,000 per month, but we have also like 12-month packages or 6-month packages. But for the first month, you can join for only 1,000 per month if you enter the code NM, which is capital E small n capital E small m, right? Just go into the subscription part, type in this code, and you can join the program for 1,000 per month. So yeah, this was about the competitive programming program that we have at Unacademy. So without further ado, let's get into the problems. And uh, for the doubts, this is a rather limited platform. At Unacademy, you can ask me doubts directly and I will be solving them immediately. But in here, please keep your doubts up until the end, right? You can just ask them in the chat and I will be looking at the doubts at the end and try to answer most of the doubts that I can answer, right? So all of the doubts I will be answering at the end of the class. So with first problem, which is sequence summation, the problem code is geek05. Here, for a sequence A1, A2, A3, etc., AN, it is known that there is this latex uh, formula, which I'm going to break up. But without looking at that, let's look at the lines below that first. In the above image, D, this thing, which is a bitwise OR, N means D divides N, right? So this doesn't actually mean bitwise OR. It means that D divides N, which means D is a factor of N, right? This is the explanation that I wanted to tell you. Let's go back into the formula. The formula says summation of D factor N. So for all factors of N, what are we going to do? The dth element in the sequence, which is AD, the sum of all these numbers is going to be 2 to the power n, right? So for all factors of n, the summation of the numbers at their sequences is 2 to the power n, right? That's what this formula is trying to say. This is a little confusing formula because I have also given this problem to my learners currently, and many of them have doubts in understanding this. So I will be explaining this properly, right? Before that, let's look at what does the program want. You're given q queries. For each query, find the sum of AL plus 1, AL plus 2, etc. up until AR. For given values of L and R, since answer is large, output it modulo 10 to the power 9 plus 7, right? The first line contains q, the number of queries, then two integers, L and R. For each test case, just print the answer. Q is 10 to the power 5 and L and R is around 10 to the power 5 as well. So if we have constructed the sequence, if we do have the sequence itself, right, then it is easy to output this. If we will just construct a pre-processed prefix sum array, and let's say the prefix sum up until AX is dpx, right? So if we have two integers L and R, then the sum of A plus 1 up until AR is going to be dpr minus dpl minus 1. That is really simple. It is a beginner level competitive programming questions, just summing a subsegment of an array without any updates, right? It can be done by a pre-processed prefix sum. But the main question is to create the sequence, right? How do we create the sequence? If we can do that, then we can do the rest of the question by itself, right? So these are some subtasks. I will not be looking into them. But the sample input is, let's say, 6 test cases. For the first test case, 1, 3, second 2, 7, 4, 6. But the sequence is going to be the same in every query, right? It's not going to change again and again. So the sequence they have given is 2, 2, 6, 12, 30, 54, 126, 240. So they're just like for the first case from 1 to 3, they're summing 2 plus 2 plus 6, which is 10. For 2 up until 7, they're summing 2, 6, 12, 30, 54, 126. They're summing this up and answering 230, right? For 4 to 6, they're summing up 12 to 30 to 54 and answering 96. Similarly, and so on, right? So let's try to look at how this sequence is created first. Let me switch to my whiteboard and then I will be explaining this on there by sketching. So this is the problem name, which is sequence summation. We have the formula summation of d is a factor of n. AD is 2 to the power n, right? This is the formula that's being used to create the subsequence. What does this mean, right? Let's keep n as one example, right? Not an example. Let's keep n as one because that's going to be used to create the array, right? So for this, the factors are only one itself. One has only one factor, which is one itself, no other factor. So this is going to be a1 is equal to 2 to the power 1. So we got a1 is 2, right? Simple. In the sub test case as well, a1 was equal to 2. Let's go for n is 2, right? It has two factors, 1 and 2, no other factors. So a1 plus a2 is equal to 2 to the power 2, right? A1, which is this one, and a2 is going to be 2 to the power 2. So this means a2 is equal to 4 minus a1. And we know that a1 is equal to 2 from this formula. So we are just going to put that there. And the answer of this is going to come as a2 is equal to 2 as well, right? So I'm thinking you do understand how the sequence creation works now. We will just go from forward. N is equal to 3. The factors are 1 and 3. We're going to have an equation which is going to say a1 plus a3 is equal to 2 to the power 3, right? But we know a1 is equal to 2. So a3 is equal to 8 minus 2, which is a3 is equal to 6, right? So 2 comma 2 comma 6, exactly similar to how the sample sequence was shown in the test case, right? Let's go to N4 and then we'll try to see how to do it for a general number and not just some constants that we're looking at. So here we have three factors, which are 1 and 2 and 4. Up until we were having only one or two factors. Here, the equation is going to be a1 plus a2 plus a4. But we do know a1 and a2 because we have iterated over the numbers. So we already know a1 and a2. So this is going to be actually 2 to the power 4. So this equation is going to turn into a1, which was 2, and a2, which was 2 as well, plus a4 is equal to 16. So a4 is equal to 12, right? Let me see if this was the value in the example. Yeah, this was the value in the example. So the values are being created successfully. What is happening is, let's take a general number, some n. It has factors. Each n greater than 1 is going to, every n is going to have a factor of 1 and the number itself, right? Which is n is greater than 1 currently. And the rest of the factors I'm just naming as k1, k2, etc. up until kt, right? So in here, the equation is going to be a1 plus ak1 plus ak2 akt plus an is equal to the power n. But because we are iterating over the range, we would have calculated this whole, all of these numbers before I have calculated to the power n, right? I would have calculated all of these numbers. So the answer is just going to be, not the answer, the value, we are going to set the value of an is equal to 2 to the power n minus a1 minus ak1 minus ak2. Basically, we want to, for a number an, we are going to substitute that as 2 to the power n minus the sum of all of the proper factors, right? Basically, a1, ak1, k2, these are all the factors of n, right? So for a number n, let me write this. For a number n, basically we are going to use this equation to calculate an plus 1, etc. But how do we do that? For a number n, we want its factors, right? If we do know its factors, then we can keep these values in this equation and get an by itself, right? So for a number n, we want its factors. And here for a number, instead of having we actually keep for each number n, we want its factors, because we want to calculate a1, a2, a3 up until a10 to the power 5. We want the factors of each number in this range, right? So instead, what we are going to do, the solution here is, because instead of factorizing for each number, which is going to take square root of n into n, right? What we are going to do for each number, x, see its multiples, right? For a number x, see all of the multiples that the number has. Let's say a multiple is n, right? So we are going to update that an minus equal to ax, because x is a factor of n, right? X is a factor of n, and for a number x, we are seeing all of the multiples x has. So we are going to do this updation because x is a factor of n, right? And this is going to work in big of n log n time. This is a sieve-like method, because for 1 we are going to see all of its multiples, for 2 we are going to see all of its multiples, for 3 we are going to see all of its multiples. So up until n, of course, the multiples less than equal to n, right? So how much time does this take? It takes big of n by 1 plus big of n by 2 plus big of n by 3. These are the number of multiples less than equal to n of 2, right? These are the number of multiples of 3 less than equal to n, right? And so on. And if you have seen how a sieve is, the tangolexity of a sieve is calculated, we can reduce this number to just big of n log n, right? So this is going to create the array, and then we'll create a preprocessed prefix sum on that array. And then we are just going to output the queries after each query comes, just the subsegment sum, right? So let me switch to my code editor, and we'll try to code it in my editor and see if it doesn't have any errors. So first of all, I'm going to declare the maximum range the numbers can come, which I'm going to initiate by a capital N with the static and constant as well. So this is going to be 1e5 plus, let's take some extra buffer outside of 1e5, so that, like, not many runtime errors come. It kind of eliminates the possibility of a runtime error, right? So for int I equal to 0, I is less than n, I plus plus, and actually I don't need I equal to 0, I need I1, right? I want to set AI. I haven't declared AI up until now. Let's declare that as well. Static int a n. AI should be 2 to the power I. Initially, I'm setting that as that, and then I'm going to subtract the value of its multiples, right? Modulo mod, of course. And what is mod? Let me declare mod as well. Mod is 10 to the power 9 plus 7. 1e9 plus 7. Right? So how do we do that? It's not bitwise XOR. This is, I'm talking about the exponentiation, but I can't do that, like easily in C++. So either I have to use the modular exponentiation code, which I have talked about in my class if you are from there, or you might have heard about that as well. But what I'm going to do, I'm not going to use the modular exponentiation. I'm going to declare a int 2 to the power I, 2 to the power I, this is 2 to the power I. Currently, that set as 1, right? And before each iteration, I'm going to multiply this by 2, right? So 2 LL into 2 power I and modulo mod. So this is going to be 2 to the power I after each iteration, right? Because currently it's 1. When we come into this iteration, it is going to become 2, and 2 to the power 1 is actually 2. Then we go into the next iteration, it's going to repeat this, it's going to become 4, and 2 to the power 2 is 4, right? So I can just declare this as 2 power I. Next, we want to do the sieve-like method, which I talked about. For each number, see its multiples. So that can be done as for int I equal to 1, I is less than n, and I plus plus. I'm going to go from int j equal to 2 star I, j is less than n, and j plus equal to I. This code will see all of the multiples I has, which are less than n, right? So for those multiples, I want to subtract aj minus equal to ai, but I'm not going to do it like this. I'm going to do it like aj is equal to aj minus ai, but I still want the whole number to be in modulo mod. So I'm going to declare that here, and I'm also going to set plus mod here so that this number whole cannot be negative. Now it has to be positive, right? So aj is equal to aj plus mod minus ai modulo mod. Perfect. Next, let's construct the prefix array. So static int dp of n. dp of 0 is going to be 0, right? Because up until there's no sum. For int I equals to 1, I is less than n, and I plus plus, I'm going to set dpi is equal to dpi minus 1 plus ai. And I also want this to be in modulo 10 to the power 9 plus 7. So I'm going to do this. Then I will just take the number of test cases. And while the test case loop is running, I will take L and R and just output dpr minus dp L minus 1. But I want this to be modulo mod, and I also don't want this to be negative. So I'm going to do a plus mod here, right? And I want a new line character. So that's there. And let's try to make this work on the sample first. And if it gives the correct answer there, then I'll try to submit it. So the compilation is complete without any problems. I'm just going to start this code. So the answers are coming out to be 10 for 1, 3. For 2, 7 is 230. 4, 4, 6, 96. These are correct. 22 to 34 is 355, 279, 822. That is correct as well. I'm looking at the web page of the problem. 100 to 300, it's coming out to be 755, 724, 992. Correct. And up until here, it's 3989, 81621. Yeah, that is correct as well. So this program is most probably correct. Let's submit this on the web page. Let me share the web page first. Right? Submit. C++14. So this is most probably going to give an AC. So I wanted to share about how you can look for, if you want to look at each number's factors, instead what you can do is look at each number's multiples, right? So you can use a sieve-like algorithm to look at each multiple a number has, right? So that was the main point of this question. And also to understand the question properly, because many people are stuck on what is the sequence going to be like, right? They don't try to see out of the formula that's given. So yeah, it is an AC. And if you're coming to the class right now, I want to give a revision of the Unacademy program on competitive programming. So let's go to this PDF. And if you are currently joining in this lecture at the half point or something, this is a problem solving session. The main problem that is really interesting in this problem session is remaining, which is Aragorn's racing dilemma, which I found very interesting and I wanted to share it with everyone, right? So I'm going to be solving this in the next half an hour. Uh, this is a part of the number theory course that I have on Unacademy. So a short introduction about myself. I'm Zeus Source on Code Forces and I'm at Code Chef. Recently joined as an educator at an academy. You can see my profile at NM. So what will you get in the competitive programming program that Unacademy has is that every educator is taking a course and you can join that course and have live classes, live interactive classes. So you will be asking us doubts. I will be solving that. I generally, solve the doubts almost immediately, right? And I will be asking you questions as well to understand what your level of understanding is right now, right? So you can answer those. I would also be giving you relevant problems on CodeChef so you can solve and practice on the topic that you studied on that class. I This is done on a forum which I'll be displaying below, and also you'll be getting doubt support from me in class or out of class, and also teaching assistants. There are many teaching assistants at an academy uh, who are really talented as well, right? So you'll be getting your doubts cleared from many talented people, which can most probably judge your doubt in like 1 or 2 seconds, right? So you'll be getting doubt support from me and teaching assistants in class or out of class, wherever you want to ask, right? So the educators, everybody is a really do have a strong background in competitive programming. There are some people who have gone to ICPC World Finals. There are some people who have IOI medals. Some people work in dream companies like Google, Flipkart, etc. These are the educators that are currently teaching at an academy on the competitive programming part. So there are like many ICPC World finalists: Tanuj Khattar, a two-time World finalist; Himanshu Singh, Deepak Kaur. There is a software engineer at Google, Murugappan. There's an IOI bronze medalist, Arjun P. Right. So all of these educators are really talented. Pulkit Chabra, really nice ratings on Code Forces and Code Chef. Also me, an international grandmaster on Code Forces. Right. So the topic wise, there is a topic wise structure in this program. There is going to be absolutely basics, which I guess are more basics of programming, just C++, Java, Python, etc. And then there are the basics of competitive programming that we are going to teach, which are STL, number theory, which I'm taking, basic data structure, sorting, recursion, greedy. And then there is the advanced stuff, which is more like the intermediates of competitive programming, or advanced intermediates, right? Segment trees, trees and graphs, computational geometry, advanced dynamic programming. So if you religiously follow all these courses, you would be able to become like candidate master on Code Forces or 5-star on CodeChef, right? Whichever you are aiming at currently. The miscellaneous are ICPC regionals plus world finals as well. Himanshu is solving the problems which have come in world finals or regionals prior to this. These are all the courses that are currently going on. So you can go back and see the videos of those courses as well, right? Those are currently at the Unacademy platform. This is uh, this is the forum that I was talking about, where the teaching assistants would solve your doubts. And this is the platform where what I was talking about, where I would be giving you practice problems, right? So if you want to see how the lectures work, there are some special lectures currently at Unacademy which are free to watch. You can go watch them. I have 3 lectures on Siva Veritas Sines. You can watch that. Also other special lectures, or you can see this YouTube video, right? And if you do like it, for the first month, it's $9.99 per month. So you can join the platform, join the subscription, and see every educator for 1,000 for the first month, right? And then there are 6 months and 12 months package as well. To apply this 1,000 rupees per month package, you have to type in the referral code, which is NM, big E, small n, big E, small m. Right in the subscription part, it will be asking you the referral code. So you do have to type this. So yeah, uh, uh, without further ado, let's get back into the problem solving part. And I would be taking this problem, which I found really interesting, right? Aragorn's racing dilemma. So I would be talking about this problem right now. So let me first explain this problem, right? What is this problem about? Aragorn, an expert ranger, has gotten bored of being the king. He decides to retire and buy some horses to race in his lawns. First, he constructs a M-lane horse racing track. Then he buys M to the power K horses with the help of Bilbo's treasure. Alas, a new evil approaches, and Aragorn and Legolas must rush from Gondor to face it. To expedite his departure, Aragorn urgently needs to know which of his horses are the first and second fastest. Order between the two is important, right? Aragorn wants to know what is the fewest number of races needed to find out this information. He does not have a stopwatch, so he can only see which horse came first, second, etc., and not an absolute measure of the speed. Help him find out this number modular 10 to the power 9 plus 7. So, in this giant text of information, what the required information is for the problem, that he can race m horses at a time, right? He currently has m to the power k horses. He would be taking some m horses and racing them, so he can know which horse came first, which horse came second, etc. And after all of the races, he wants to know which is the first fastest and second fastest, right? He wants to know which horses are the first and second, right? The question asks, in how many races can you find this information, the minimum number of races to find this information. You might have seen this problem already. It is a general interview puzzle question, right? It's generally asked in puzzles like, you have 30 horses and you can race 7 horses. But it is a little different from it because we have to code it. In generally interviews, you just have to write down the formula, and the limits are also small, right? In this, it's m to the power k, right? So the input is just the number of test cases, and then there will be two integers m and k. We have to find the number modulo 10 to the power 9 plus 7. Test cases are around 1,000. M is around 10 to the power 9. K is around 10 to the power 4, right? So there is not much that you can do in this. You cannot go big of big of m, right? Absolutely, 10 to the power 9. You can go big of log m. You can kind of go big of k, but it would be around t is up until 1,000 into 10 to the power 4, so it would be 10 to the power 7, which would work, not in the dangerous area. So you can go big of k as well, but I think the answer wants a big of 1 or big of log m or something, just in big of log answer, right? So the sample input, let's go through the sample input first if you do not understand the question right now. We have 1, 5, 1. So we have m to the power k horses, which are 5 horses. Currently, we have 5 horses. And we want to find the first and second horse, and we can race 5 horses at a time. So we'll just keep the 5 horses in the lane and, make them run. And whoever comes first and whoever comes second is going to be our answer. So we need only one race to find out this information, right? So the sample output is 1. Okay. So let's go to the whiteboard and try to reduce this problem into what we can find out, right? So let's share this. Wait a second. Let me share this. Sorry, I think, yeah, I'm sharing my screen. Sorry. So yeah, this should be visible right now. Let me clear my canvas. Let me first write down Aragorn loves racing, right? So in here, we have m to the power k horses. We can race m horses, and we want to find the first and second, and we want to find it modulo 10 to the power 9 plus 7. right? Let's take some examples. I mean, not examples. I want to see what would happen if I do conduct a race. Let's say in the start, it's not really up until like which horses we are going to select. Let's just select M horses, right? I have M horses like A, B, up until A1, sorry, A2, AM, right? I select these horses and then I'm going to race them. Somebody's going to come first. Let that be X. Somebody's going to come second. Let that be Y, and the rest, let that be the rest, right? So the rest of the horses are just not going to be first and not going to be second in any point of time, right? Because those are slower than the second person here, second horse here. So the rest of the horses I can just throw in the trash, because these aren't going to be the first and second horses, right? So I'm getting this information that out of this many horses, right, uh, M minus 2 horses are not going to be of use to us in any point of time after this, right? The next information I'm getting is Y is slower than X, right? This is the second information I'm getting. And this is an important information because if let's say I conduct another race and in there I'm selecting AX and some some other numbers, let's say AM plus 1, AM plus 2, etc., right? Some M horses, and I'm keeping AX there. Now let's say M plus 1 comes here first, or some, let's say Z comes here first, right? And second is X, and the rest are going to be trash. We can just throw them out. We don't require those horses, right? But in here, now we know X is less than Z, but we knew from before that Y is less than X, right? So we can throw out Y as well, right? So these are the two informations that we get from each race. One is the below M minus 2 horses are not going to be applicable, just throw them out. And the next information I'm getting is just one inequality, which is X is less than Y. Y is less than X, sorry. Is there any other kind of information that we can think of that we are getting from this race? I don't think so. I can't think of anything that we are getting out of this, right? So with these observations out of the way, let me write down these observations for everybody to see. If we conduct a race, the first observation is last M minus 2 are useless. And first is greater than second, right? These are the two informations that we are getting. Now let's try to find just the first person. Let's change the question for a bit and try to think in that direction. Let's say we don't have the limitation that we have to find the second horse as well. We just want to find the first horse, right? So in that, it's really easy. We just have a set of m to the power k horses, right? We have a set of m to the power k horses. Let that be s, right? Let me write this down a little bit. So we are going to maintain a set S, which is the possible first people, right? The possible first horses. Let that be S1. And initially we have m to the power k. We have a race, and the below m minus 1, the last m minus 1 horses are just going to be discarded from the set, right? They are not going to be in the set anymore. So in one race, we can get to m to the power k minus m minus 1. Then we select another m horses from the set randomly, right? It can be the person it can be the horse that came first in the first round, or the another horse. It doesn't really matter which horse we are selecting. But in the second race, we are reducing the set to m to the power k minus 2 m minus 1, right? We do this like for eternity. And finally, we are going to have one horse, right, in some x races. So what is going to be the x? X is going to be m to the power k minus 1, because initially the size was m to the power k, and in last it's it's 1. So I'm having the delta here, m to the power k minus 1. And in each race, how many horses are being sent outwards? It's m minus 1, right? And if this isn't exactly divisible, then we are going to have a ceiling on this, because we want to throw this many horses out of our set, right? We want to throw these people out of the set, and we can in one race throw this many horses out of the set, right? So it's going to be n to the power k minus 1 by m minus 1 ceiling. And if you do know a little bit to maths, m to the power k minus 1 is actually divisible by m minus 1. So we don't require the ceiling function, right? Because let me write that as well. M to the power k minus 1 is actually m minus 1, 1 plus m square up until m to the power k minus 1, right? So m to the power k minus 1 is always divisible by m minus 1. So we can just write x is n to the power k minus 1 by m minus 1, right? We require these many races to find the first horse. Now to find the second horse, I'm going to declare a second set, which is S2 possible second horses. And what is going to be this set? It's the horses ejected from S1, right? The horses which are ejected from S1 and came second in their race, right? Those horses I'm going to keep in the S2 because these horses are probable of being the second. But there is another limit requirement here for a horse to be in the second this set, right? In S2, the another requirement that we have is the person, the horse that lost to must be in S1, right? Because if the horse that they lost to isn't in S1, maybe let's say they lost to some horse X, right? And X was initially kept in S1 and Y was initially kept in S2. Now X comes second in another race, or X, gets in the last M minus 2 horses, then Y is going to be ejected from S2, right? So these are the two conditions that we require for a horse to be in S2. The horse is ejected from S1 and came second, and the horse that lost to must be in S1. So these are the two conditions that we require for a horse to be in S2, right? After like all of the races are completed, all of the races in S1 are completed, which means I'm talking about the X races, which are n to the power k minus 1 by m minus 1, right? After all that, there is only going to be one horse remaining in S1, only one horse. And all of the horses that lost from this horse, right, that lost from this horse and came second are going to be in S2. So S2 is going to be in final after all of these races is going to be the horses that lost to the first fastest and came second, right? So how many, let's say the size of this set is, let's say something A, right? Then how many races are required to reduce this set to 1? It's simply very similar to what we did in the first case. We are just going to do A minus 1 by M minus 1 ceiling, right? So we want to minimize A. We want this to be minimum, right? So we want the winner horse to have had as few amounts of races as it could have, right? But we don't know which one is going to be the winner horse. It can be any one of the horses. So we want all of the horses to have the minimum number of races they can have, right? So as no matter which horse wins in the final, no matter which horse comes first, the A A, which is the number of horses that lost to the first fastest, right, and came second, are going to be minimum. So the number of races the first fastest horse has is minimum, right? So this is exactly equal to the number of the races that first fastest had, right? The number of races the first fastest had, that is going to be equal to A, right? So let me try to depict this in a graphical manner, right? We have some horses A1, A2, A3, etc. AM. We're going to have a race between them, and I'm going to declare that as a tree. And this node depicts the winner that came out of this, uh, right? The winner that came out of this race. Let's take the next m minus 1 horses, am plus 1, am plus 2, etc. And I'm going to have I'm going to have a race between this winner and all of the next horses that are coming, right? So let's say only these many number of horses are there. So if I had a horse from here as the winner, right? If A1 is going to be my final winner, then he has had 2 races, right? But if the horse was from AM plus 1, right? If it was AM plus 1, he would have had 1 race only, and A would be 1. So to minimize this to minimize A, we can see from this graph, right, that the tree should be as balanced as possible. The height of the graph should be minimum, right? To minimize A, the height of this tree should be minimum, right? Let's take an example here, because I feel not many people would have got this. So let's take an example of M is, let's say 2, right? And K is, let's take this as, let's take this as 2 as well, right? So in an arrangement of races that I'm going to have, I have the first horse here, the second horse here, the third horse here, 4 horses here. There are going to be 4 horses because 2 to the power 2 is 4, right? I have a race between this. This is the horse that came out to be winner. I had a race between the winner of here and here, and I had a winner of here and here, right? Now, if this horse is going to be the winner, then he would have had 1 race with this person, right? And this person is going to this horse, sorry, I keep saying person, this horse is going to be the second fastest, right? But if this horse comes out to be the winner, right, so he would have gone from here to here. So either this horse can be the winner, or this horse can be the winner in the second fastest, right? Either this horse could be the second fastest, or this horse could be the second fastest. There is no knowing which of these horses is the winner. We would have to require another race for that, right? But if a horse has come winner from this position, right, he would have had 3 races. So first he's going to win against this, then he's going to win against this, then he's going to win against this. So we don't know any way of we don't know which of these 3 horses is going to be the winner. So we can have here 2 horses, 2 races, right? 2 extra races. So here we have 1 race, we have 1 race, and here we have 1 race. So here m to the power k minus 1 by m minus 1 is actually 3, right? Because 4 minus 1 by 2 minus 1 is 3. So we had 3 races first, right? Then let's say this is going to be our winner. Then we have 3 more horses, and 3 by 2 minus 1, 3 minus 1 by 2 minus 1 of ceiling is going to be 2 by 1 ceiling, which is 2. So we would have a total of 5 races, right? But this is not efficient, right? We do not want this. We want the height to be as balanced as possible. So what is the efficient, what is the optimized way in which we can create this tree? We can create this tree like this, right? So no matter which horse is going to be the winner, right? All of the horses would have had only 2 races, right? So the answer here is going to be the m to the power k minus 1. Sorry, not minus here. M to the power k minus 1 by m minus 1 plus 2 minus 1 by 2 minus 1 ceiling. So here the answer is going to be 4, right? So we want as balanced a tree as we can get. So in a situation where we have general m to the power k and we can select m horses in each, right? The tree is going to be looking like the uh, complete balanced tree where each internal node has m children, right? So the root would have m children, and then each children is going to have another m children, and then each of those children are going to have another m children, right? And after k levels, we are going to approach the leaves, which are m to the power k horses, right? Basically what I mean is I'm going to group these m to the power k horses in m to the power k minus 1 partitions, where each partition has m horses, right? I'm going to have a race between each m horse, and the next level I'm going to have mk minus m to the power k minus 1 horses, right? And then I'm going to similarly partition those into groups where each group has m horse, going to have a race between each group, and then the next level I'm going to have m to the power k minus 2 horses, right? So initially we have m to the power k horses, then m to the power k minus 2 minus 1 horses, etc., up until m to the power k minus k horse, right? This is one race. This is one race. Not actually one race, but for each horse, we have only had one race right now for each horse, right? So up until here, we are going to have k races, right? So the final answer is actually going to be m to the power k minus 1 by m minus 1 plus k minus 1 by m minus 1 ceiling, right? And how do we like calculate this? We can just calculate the modular inverse of this and multiply by whatever the modulo this number comes, right? So it's going to be really simple. The code is really going to be simple, right? So let me code this and submit for AC. So let me switch to my IDE. I'm thinking there would be many doubts related to this problem. So once I submit this problem, you can ask me your doubts relevant to this topic, or can be off topic as well. Just ask me those and I'll be looking at those questions after I get the AC, right? So let me share to the this editor. You should be seeing the editor. Let me take the function that I have for modular inverse, because I'm going to be needing that. Actually, let me code this in my standard template only, right? Because it's a really simple formula. You can understand even if I do code this in my standard template, right? So in each test case, right? Let me remove the confusing parts from my template. LL means long, right? So I'm taking the numbers in long. And let's take this out as well, right? So this is the main function. I'm going to have two numbers for each test case, which is m and k. And what I want to output is m to the power k in modulo mod, right? So m to the power k modulo mod, and I have set mod in my template as m1, right? So this is modular exponentiation. I have taught this in my number theory class. You can look for modular exponentiation in online as well. Generally, it's called as modular exponentiation or binary exponentiation. This is really a really simple topic. And another topic that I would be using here is modular inverse. This is again another simple topic, but yeah, I wouldn't be teaching modular inverse and modular explanation right now because those are topics of their own, right? So mod I m minus 1, and I just saw that this should be m to the power k minus 1, right? So to do minus 1, what I'm going to do is plus m1 minus 1 so that the value doesn't come out to be negative, right? So I want to multiply this with this modulo some m1, right? So this is going to return m to the power k minus 1 by m minus 1 modulo m1. And I want to add this with the k by m minus 1 ceiling. And to do ceiling in C++, what I do is just add um, uh, the quotient minus 1 in the numerator, right? So I have actually this should be k plus m minus 3. So what this means is I have k minus 1 here, right, which is going to be the original numerator. I want to calculate the ceiling of k minus 1 by m minus 1. So to calculate that, because this division is going to give me floor and not ceiling, right? So to have ceiling, I'm going to add m minus 1 minus 1, which is the quotient, not the quotient, denominator. The denominator is m minus 1. So I'm going to add the denominator minus 1, right? So this all reduces to k plus m minus 3, right? I'm going to add this, and I want the whole answer to be in modulo m1, and I would just output this. So this is just a single line code, right? There isn't much that I have done here. Of course, there is a modular exponentiation and modular inverse, but if you have that in your template already, then you just have to code one line, right? So let me see if this works. uh, the test case was sample test case was 151, so it's going to give 1 here, but this is a really simple test case. Let's try to do for the example that we took. 1, 2 and 2 should give 4. Yeah, it's giving 4, right? Let's copy this entire code and submit this in the problem which page. So let me share my problem. Yeah. So in here, I'm going to submit this entire code. Do not like I do have many functions in my standard template, but the important part is just modular inverse, which I have implemented using extended GCD algorithm, or you can call it that. You can call it as Euclid's GCD algorithm. And I also have binary exponentiation or modular exponentiation, which is this, right? I am only using these two functions, and finally I'm doing the main code, right? So submit this in C++ 14. Yeah, there's the AC. So this concludes the session that we had. So if you do have any doubts, just ask them in the chat right now. I'm guessing there would be many doubts for the second problem, but if you do have any doubts, and not related to these problems as well, just want to ask me some questions, you can ask those as well. Also, like there's a interface between me streaming and you guys seeing. So up until I get the doubts, I want to uh, tell you all about the feedback form which we have in the description, right? So down below in the description of this video, there is a feedback form which would let me know if I'm going too fast or going too slow, or like should I improve on my teaching skills and where should I improve. So please do fill that feedback form, right? Because it helps me to understand where do I have to improve and where do I have to work next, right? So you can find the link of the feedback form down in the description. Just click that and please give your feedback of yours. If you do have doubts uh, after this class as well, you can just ask me that on CodeChef or Codeforces, wherever you want to ask me doubts. My handle at Codeforces is users, and my handle at CodeChef is nm. This at CodeChef and this at Codeforces. You can ask me your doubts here if I can't see those doubts right now. So let me look at the chart myself, right? So we have Amira saying which contest question is this from, right? You can see that from the question code written there. Anu says, why are you using static? So I'm using static because it allows me to make large arrays. You don't really have to use static, but it allows me to use large arrays. That's why I'm using static. Uh, because static goes into the heap and stack goes into the normal arrays that we create go into the stack, right? So there is this difference which allows heap to have more space than just creating an array normally. Then we have the modular inverse does not always exist, right? So how are we accounting for this here, right? So the modular inverse always exists for a prime modulo, right? Because we have two numbers a, we want to find x to the power minus 1 modulo some, let's say m. So if m is actually prime, then we know that x and m are going to be coprime. And the existence of modular inverse only depends on is x and m co-prime, right? So we don't have to account that for here because m is given to be prime, which is 10 to the power 9 plus 7. Even if it is not given in the question, you can just find out that this is a really famous prime, right? You must have seen this in question. This is always the famous prime to go to. Where do you practice questions for div 2 C, D, E, right? So the questions for div 2 C, D, E, I would practice on, div 2 C, D, E, because that is the best place to practice those from. Maybe just to go back to the previous contest, select div 2, the problems which I have not solved yet, and just go to the C, go to the D, and go to the E. Maybe you want to practice topic wise for those problems, but that isn't really possible because the topics that comes in those level of questions, C, D, and E, are really varied, right? So you can't really just pick like, okay, dynamic programming. If I cover dynamic programming, I'm going to solve C, D, E forever, right? You have to cover all of the topics. You have to cover graphs, you have to cover dynamic programming, number theory, and everything, and then you will be finally able to cover C, D, and E. Also give contests. Practicing in contests, like makes you the best prepared for contests themselves, right? I want to learn data structure like try and Fenwick tree. Which source is best for that, right? So Fenwick tree and try. I'm thinking you should pick a graph based course, maybe a course on graph, like currently Pulkit is taking, right? Fenwick tree, I'm not sure if Fenwick tree is going to be covered in that, but try surely, right? Because try is a standard graph data structure where each number can be represented in like just these ways, right? So this is 0, this is 1, this is 0, this is 1, and I want to store 0, 1. So I would be storing that in this node, right? This is the basic summary of try. This is really simple. You can just like even Google that and like try to learn that on your own as well, right? Just it wouldn't take long. These are like really small data structures. I'm guessing it would take 1 hour for you to completely learn about try. For practicing about try, that's a different problem, but even for that it won't take you more than like 4 to 5 hours, right? Fenwick tree, similar. It would take you at most 1 hour to learn about Fenwick tree, and for Fenwick tree, it would take you forever to practice and be perfect in it. But yeah, you can go down that route as well. How to solve last 4 or 5 questions on CodeChef long? So in CodeChef long, what I think the main objective is to make you go and learn the topics, right? So you would want to not plagiarism. I'm not talking about like if you want to learn about the topic, just ask your friend, hey, what topic does this question cover? No, it wants you to like try to search, like if you do know the concept already, right? It wants you to cover that concept. It wants you to like try to search for the concept yourself, learn that big concept, because generally the last 4 or 5 questions on CodeChef long has a really big concept, right? Generally the last question on CodeChef nobody has heard of before, but they want you to like learn this topic in this long challenge. So they want you to go there and learn that. What do we do if X and M are not co-prime? Then we cannot find a modular inverse. X and M, if they are co-prime, then only a modular inverse exists, right? If this was not the case, then I guess that's why k is given to be less than equal to 10 to the power 4, because then I think we would have to calculate, instead of doing m to the power k minus 1 by m minus 1, right? We would have to actually calculate 1 plus m square plus m cube, etc., up until m to the power k. So you can find the modular exponentiation even if x and m are not co-prime, but you would have to go like in this fashion, right? You would have to first calculate 1, sum that up with m, sum that up with m square. This would take you big of k times. However, in here, it's taking you just big of log whatever the modulo is time. Here also there would be no, there would be a log function here, but it would take you big of k time. But in general, we can't find x inverse if x and m are not coprime. All right. I think this would be all. If you do have any doubts other than these doubts, and you want to talk about your journey in competitive programming, etc., right? I have told you about my handles on Codeforces and CodeChef. Go message me there. And if you enjoyed this lecture, or you found this lecture to be boring, or you want this lecture to be more explanatory, or you want this lecture to be fast, go down to the description and fill the feedback form, because it helps me understand how should I proceed further, right? So this was a session on problem solving. I will be ending this lecture here, and see you guys in the next lecture, right? This has been competitive programming with the CodeChef, learn competitive programming with CodeChef, right? So bye.